The ocean may be the most challenging place to call home. The flow of currents, the ebbings of the tides, and the movements of the waves make it a dynamic and ever-changing environment. The challenges it has imposed on its inhabitants throughout the passage of time have caused them to take on an astounding variety of shapes and lifestyles. Among this endless array of variation are two groups of vertebrates that at a glance look like extremely close relatives, who have always been masters of the sea. However, the truth behind these two lookalikes is far more fascinating. Ichthyosaurs were a clade of marine diapsid reptiles called the ichthyosauromorphs. Dolphins are part of the suborder Odontocetes, whose members are part of a clade of marine artiodactyls called the cetaceans. Whilst these two groups do appear to be morphologically similar to one another, they are not closely related, with their last common ancestor likely living around 250 million years ago. However, there are a few reasons why they look so similar. Firstly, both evolved from a terrestrial ancestor that became secondarily aquatic. A study done in 2001 suggested that dolphins and cetaceans as a whole first appeared in the early Eocene. It suggested that the earliest ancestors of modern whales were pachycetids, such as Indohyus and Pachycetus, which were amphibious mammals that likely foraged for fish along the coastline of the Tethys Sea. After a few million years, they developed into animals like Ambulocetus and Remingtonocetus, which were not unlike modern otters in terms of lifestyle. As these animals spent more time in the water and started venturing into the sea, they traded their legs for fins and flukes and evolved into the wholly aquatic basilosaurids such as Perurocetus, Tutocetus, and Basilosaurus itself. And in the final days of the Oligocene, a creature like Olympicocetus gave rise to the masters of the Cenozoic oceans, the Odontocetes. Although it likely occurred in a similar fashion to their mammalian lookalikes, we do not know for sure how the terrestrial ancestors of the ichthyosaurs came to be, as no such fossil has yet been found. The earliest known relatives of the ichthyosaurs so far found are the Hoopensuchians, such as Hooposuchus and Eratomorphus. The first true ichthyosauromorphs known are Carthoichthys, Scalerocormus, and Chauhusaurus. For a time, most ichthyosaurs had a body plan very much like this, long and serpent-like. This was not to last, however, as creatures like Myxosaurus soon gave rise to the Neo-Ichthyosaurians, which went on to rule the seas of the Jurassic Age. Something of note with both groups is their swimming style. Early forms of both ichthyosaurs and cetaceans were long and serpentine in shape, and thus are thought to have moved in an anguilliform or subcaringiform fashion, meaning that they would flex almost their entire bodies in order to provide forward thrust in the water column. These methods of swimming require high amounts of energy expenditure, so as the two clades became better adapted for swimming long distances, they evolved deeper, shorter bodies with differentiated caudal vertebrae and high aspect ratio lunate fins and flukes for carangiform and even thunniform swimming motions. These forms of swimming only required them to flex the lower half of their bodies, which made them far more hydrodynamic. This in turn allowed them to travel at high speeds for hours at a time. Oceanic life poses many problems. One problem is how cold its depths can get. In response to this, both ichthyosaurs and odontocetes evolved a layer of blubber to protect them from the cold, with counter-shaded colours to better conceal them from their prey in the depths below the waves. Another problem posed by life beneath the waves is the notion of how to find your way around in its vast expanse. Odontocetes solved this by evolving a melon and monkey lips which allowed them to echolocate with extremely high levels of precision. Ichthyosaurs solved it by evolving some of the largest eyes relative to body size of any vertebrate, enabling them to spot even the slightest movement of a fish in the gloom. One final trait that both groups share is the orientation of their offspring at birth. Both ichthyosaurs and cetaceans evolved to give birth to their young tail first. The most commonly accepted reason why derived forms of both groups usually gave birth tail first is because head-first births led to an increased risk of the newborn drowning during birth. In conclusion then, ichthyosaurs and dolphins represent fascinating examples of convergent evolution. Their similarities arose in order to combat the same challenges of living in a marine environment, and these adaptations allowed them to overcome the challenges of returning to water and allowed them to become masters of the sea.